Hello and welcome to the next episode of CS50 Problems. Today we are going to talk more about array problems, and we are going to improve our code from the previous episode a bit. And as the next one, we will pick up the Caesar problem, which is the next in the line. So we solved readability, and we are going to solve Caesar and then substitution, which is a more complex version of Caesar, but just a tiny bit. So let's go straight to the point. First of all, let's check out our code that we have seen already. And as I said in the previous session, we are doing it slightly inefficient. We can do it much better, and we can see clearly the pattern that we are following here. So we are iterating over the whole text every time, and we are just checking against the predicate, and then we are incrementing some variable. In this case it's sentences number, but in other case it's words number. So calculate letters number is also going through the whole text, but it's checking a different predicate. So we can improve it a bit. Let me make the program first. Oh, actually we need to change directory first. So let's do that. And now let's make the program. Okay, and now we can run it. And we can copy the example from here. From there, we can copy the example. Let's say this one. And let's try it here. So it's grade 10. That's great. Okay, so let's improve our program a bit. So in other language like a JavaScript or a Python or other higher language, higher level language, we would do something like map or filter or something like that, and we might just use this as our template or some sort of like a boilerplate, and just extract the essence. So in our case it's just checking predicate and incrementing some number. So in other language we could use a built-in function like reduce or map with slightly modified output, but in our case it's C, so we have to follow what we have here and what is it, what's built in basically in the language. So we can make a for loop just once, and then using some if statements we can calculate what we need, and that would be our improvement. So let's do that. So in order to do that we need to create a for loop here. So let's do the normal for loop. So we need to create a counter and use text here as our end condition, and we need to increment the counter. So in order to check the first thing, we need to copy this bit. And if it's space, then we want to increase words number. So we can declare it as I did. Basically, instead of calling the function, we will initialize this variable with 0. Same thing with sentences number, and letters number also would be 0. We can make it explicit, so we can use else if here. So let's do that. So we did this thing already. We've done this. Now we can move on to the sentence and usage here. So we are checking sentences, so we need to increase sentences number counter. There we go. And in other case, we know that it will be a letter, or maybe not. Actually, it might be something different. So else if it's valuable, it's a valid usage here of else if statement. So we have this alpha, and we want to increase letters number variable. Okay. So now we can comment out this code, or we can even just run the program and just don't use them. So we don't need those prototypes anymore. And let's make the program. I forgot about semicolon, as always. I wish we had something like prettier or something like that, but maybe it's maybe we will have time to discuss that later on in this series. We will see. We are just started with the C, so we have to struggle a bit in order to admit the better solutions later on. Okay, so let's make the program. And let's run it. Okay, so let's copy this text here. And we can see that the grade is still 10, so it's working. Now we can remove our old code. Here. Okay, let's make this program once again. Let's run it. Let's copy and paste the example. And the grade is still 10. We can also use check 50. just to make sure that all tests are passing. Let's wait a bit. Oh no. It's not working properly. That's interesting. Why is that? We are checking if this is a space, if it's a sentence end, and in other case we are checking if it's alpha. Oh, we need to add one words number at the end. I think that's what's going on there. So words number should be added once. Let me make this program once again, and let's use check 50 in order to check whether this fix is correct. Yeah, there we go. Okay, so now we are sure that our program is a bit more efficient, but it's also correct because our tests are green. So that's great. Okay. Then we can move on to Caesar problem. So let's jump right in. We need to go to problem set 2. We have Caesar. So let's read the introduction for a moment. Okay, so I think the example would be the best. Basically, we want to shift alphabet letter by a number of steps that are our key. So, for example, if the key is 1, then we want to shift by 1 in alphabet. So E becomes F, L becomes M, and so on and so forth. But the key could be different than 1. It could be, I think, 13 or 7. Let's watch the demo actually. Okay. Let's watch the demo till the end. Okay, so if the key was 13, it would give the result UV Gurer from the plain text hi there. But if the key is equal to the number of letters in the alphabet, then we would get the same answer as plain text. So our input is the same as the output because we went full circle, and we are going to use mode operator, or I think it's called reminder operator. Basically, % sign For example, we can use it like here. So if we add pi plus k and we use this operator and we divide by 26, then if our number was 28, the result would be the number that was the result from this added two numbers. So from the sum, we would get 2, because 2 is reminder of dividing by 26. So the definition is here. Reminder when dividing by 26. Okay. So let's read the specification. Okay. So our program must accept a single command line argument and non-negative integer. Let's call it k for the sake of discussion. If your program is executed without any command line arguments or with more than one command line argument, your program should print an error message of your choice and return from main a value of 1, which tends to signify an error. Do not assume that k will be less than or equal to 26. Your program should work for all non-negative integral values of k. Less than, in other words, you don't need to worry if your program eventually breaks if the user chooses a value of k that's too big or almost too big to fit in an int. Okay. So for example, if we chose 27, then A should become B, since 27 positions away from A, it's just 1, because 27 divided with the remainder by 26 is 1. That's the whole thing here. Okay. So we need to do some input gathering. We need to use getString method and stuff like that. So I think we can jump into it. I also submitted this problem previously, but don't worry. I'm going to remove all of the code and write it from scratch right now with you. And first of all, we want to include our cs50.h because we want to use getString from this library, which is really handy. So in our case, it's main function, but we don't want to pass void here because we want to gather input from the user. So let's actually use a hint here. Yeah, so we need to convert argv to an int. Okay, so we could use atoi method to achieve that. Let me check. Convert string to an int. What if it's not the string that is convertible? Let's actually check it. So we can use our printf function once we include standard io.h. Use printf function and print here something that it's not string, and use this atoy. So this atoy lives in standard lib. Okay, so we need to include it as well. Let's include it. Don't forget about those diamonds. Okay, so now we can use atoy. Let's use person I to print an integer, and we want to use atoy on something that it's hello, for example. I'm not sure what would be the result, but let's see. So we need to use cd command and change directory to Caesar. I think I made a typo. Yeah, there we go. Okay. Let's make it. Okay, and now let's run it. Okay, so it's returning 0. That's interesting. Let's try exclamation mark. Still 0. So atoy probably is returning 0. Okay, so I think for our case we can check against 0 anyway. Okay, let's assume that it will be a string, but we can also assure that it's a number by using one of the functions there. I'm pretty sure it's a digit. So every character has to be a digit. And that would be it. Okay, so let's make sure that is valid key function is returning a boolean, and our parameter would be a key, string type, string key, and we want to process it. So let's assign a key length to the variable. So we want to use string len, and in order to do that we need string.h, and for key for int I0 we want to check if it's digit or not, but it lives in the ctype.h. ctype.h. So in the ctype.h, this function lives, and we can use it here. So if is digit, it's key at I position. If it's a digit, if it's not a digit, then return false. In other case, we want to return true. So if it's not a digit, we want to immediately return false from our function. And by doing that way, we will make sure that we are only going to process a string that contains only digits, which is really good because our atoy function will take the string as an input. So we want to firstly use argv here, which is string argv, right? I think so. Don't remember. Okay. Now we know the amount of arguments. Okay. So our argc, it's number of arguments, but there is a caveat, I think. One command line argument. So argc, I think it's argument count, but I'm not sure. Let's print it. Argc. Number of arguments. Too many quotes, double quotes, okay. Okay. Now let's run it. Let's make it first, and now let's run it with. Okay, so we have 4 arguments. Why is that? Because the first one is a name of the program itself, I suppose. Yeah. So if we check argv at 0, we need to make the program first. I think something it's messed up. Let me clear terminal, and now let's make this program once again. Sorry for that sound, but it's I think CS50 terminal thing, not sure. Okay, so let's make it. And let's run it. With 1. So we can see here that it's exactly this. So it's the name of our program, our file. Let's make it more prettier. It would be a better formatted code. I mean output from the terminal, but anyway, let's make it, and now we can see that it's actually this thing here. So if our argv is greater than its length is greater than 2, we have an issue here, and we need to react somehow to this. So let's first focus on this line. So your program must accept a single command line argument. So we need to check if argc is equal to 2. If it's not, then we can immediately return 1. And we can print out the message. And we can actually test it. Let's make the program, and let's pass more than one argument. Okay. If it's not equal to, sorry, my bad. Now, there we go. Let me add new line character here, so it will be better formatted. Let's make it and let's run it. Okay. So now we are done with this point. Sorry, that's my phone. Okay, let's go with the third point here. So if our program is executed without any command line arguments, our program should print an error message of our choice. So we can use this one. I think it's pretty good because we are informing user how this program is supposed to work with what input is required to make it work. And we can combine our conditions here. So if argc it's not equal to, or we can check our is valid key predicate. So if it's not a valid key, so it contains anything else than digits, so for example exclamation mark or anything, it will also go there and print the required message and return 1 as a exit code. So in our case, the text would be, or our key, it would be the first at the first position, so in the first index, and we can use it like this. And now we can make our program. Oh, we have to declare the prototype. Sorry about that. I totally forgot to include it. Okay, so let's make Caesar and let's add exclamation mark. Okay, there we go. And if it's 1, then it's working just fine. So that's the validation part. So we don't want to assume that it's less than or equal to 26. That's okay. So our program must output plain text prompt. So we know how to do this. It's easy. We can check against, or rather we can use getString method from cs50.h. So it's plain text, getString, plain text. And then we want to ask for cipher, and then we want to compute our cipher and output it like so. It will be a result of our function, and then we want to print the result here. So it would be cipher text, cipher text, person s, and cipher text. And we want to compute it here. I think the best way would be to just make a new function, so our code would be nicely separated, and we won't mix up many things in one place, which is always good. So let's make it, maybe let's call it, I don't know, cipher, or maybe encode, maybe just cipher, or Caesar. Let's make it, let's name it like our program, so it's Caesar. I think it's like this. Okay, so as an input it takes plain text, and also our key, right? So we want to extract our plain text length. If, oh, sorry, plain text length. That will be the first one. And the second one, oh, actually, we only want to have a plain text length here. And now we can write for loop. So it's int I equals 0. And I, it's less than plain text length. And we want to increment our I, our counter. And we want to, I think, do this 1 by 1. maybe in place, because we could copy the string. There's a string copy, but I'm not sure if I'm going to do that. I think we are going to stick to the easiest possible solution here. So we want to rotate. Firstly, we want to check if the character is alphanumeric. So it's alpha. If it's alphanumeric, then we can do the rotation. So it's plain text type position. If it's true, then we want to rotate, and we will do this by just changing the character at I position in place, so without any copy. So we want to get existing character. Then we want to add value of key here. And of course we can divide key by 26, which is totally fine, because if we want to rotate, for example, 27 positions, it is the same thing as we would do with rotating by one position. So it doesn't matter. At least I think so. Maybe the truth is a bit different, but we will see. Okay, so that's one thing. I'm a bit confused here because this formula is a little bit different. I don't think it would be the same result. Actually, we need to follow the formula, because we want to rotate the result of the whole calculation, not the key itself. Because if we would need to rotate the same thing once again if I do that, but I think it doesn't matter, because with the previous approach we would need to do the same thing here. Because, for example, if we are at the end of alphabet and we add 1 or 2, we would end up, for example, with 28 as a result, which is beyond 26, and 26 is our upper boundary. So in order to simplify things, we want to just divide once after adding key to the plain text at I position, which is a letter at I position. Okay, so that's the whole rotation. Let's use our function here. It's called Caesar. And let's use plain text variable and key, which is k in this context. And we also need to parse k. So it's int key. And we want to use our atoy function, so it's k. Let's do it that way. We don't want to forget about our semicolon here and here as well. Okay, and we want to return plain text after doing our work here. Okay, let's make it, but firstly let's include the prototype here. And now let's make it. Oh, I forgot about the semicolon once again. Okay. Oh, it's int. My bad. Now it's semicolon again. Okay, there we go. Hi there. Okay, something went wrong. For sure. Because our ciphertext is basically nothing. We only got spaces, which is really, really bad. What went wrong? Let me check each step. So we are going to use printf function. So it's I position. And it would be a character, so %c plain text at I position. Now let's make it once again. And let's use a new line character here, just for the sake of readability. Actually, I think I didn't make it. Hi there. Okay. So looks like we are not doing good. No, we are doing really bad thing here. I think we can convert it to the digit, but maybe we could use some handy function here. Is lower, is digit, to lower, to upper. I don't think so. I think we need to convert it with this trick. And make it always upper as well. I think this should work. Oh, actually, not sure. I think we should let me check one thing. So we want to convert it to a digit. But we want to also check if it's uppercase or not, because we don't want to mess anything. Let's check the hint. Okay, so I think I might have an idea. So we need to check whether it's upper or it's lower, and then we have to subtract upper A or lower A accordingly, and then add lower A or upper A. So our char that will be basically our second second thing in subtraction. It would be A in uppercase version or in lowercase, but we have to check. So it's our base char. I would name it that way. So it's to upper is upper plain text I. We want to check whether it's upper. If it's upper, then we want to return A in the uppercase version. If it's not, then we know that it's lowercase. So it's just lower A. So in order to make it work, we can assume that here we are using this version because we don't want to check whether we have to use to lower or to upper and use this. We can do that trick here and just use hard-coded version because the result would be the same. We are going to assume for now that everything is uppercase, and then we will have a right index. So the most important part is to add here the lower A or upper A. So it's in our case it would be a base char, but it would be determined after checking here. So this base char will be aware if our initial plain text that I position was lowercase or uppercase. Okay, so I think we have too many parentheses here. Yeah, let's clean it up a bit. So that one is not matching for sure. So we have this one. It's matching. This one. We need another one. Okay, and now we are good to go. Let's check. Semicolon. That's my bad. Space. What? Base char. Base char. I don't get it. Why? char declared here. It's not a base char. Why? Oh, okay. It was in a different scope. Okay, I get it. Now it's working. I think it was because if I put it here, it was attached to the if statement somehow itself, and this is the other scope because we have a block here, and probably this block didn't have access to the if statement scope, and that's why we got this error. But anyway, let's continue with our program. Hi there. Yeah. We have everything right, and of course we stick to the proper casing here. So this trick actually worked. I'm really happy with that. So let's remove our debug statement. Let's remove it. Let's put it once again, and we have UV rare, which is exactly what we had here. So that's great. And I think now we can use check 50 to make sure that everything is correct. Yeah, everything is correct, and that's great. So now we can submit our problem once again. Actually, let's check the styling first, because I assume that I have many styling issues here. I was right. Only spacings. Yeah, and the order of includes. Okay, let's apply changes. Let's check it once again. It looks good. So now we can copy this link from submit 50 and use it here. In order to check our program, whether it's correct or not. So let's go to this page, and we can see that we got 11 out of 11 and 1 out of 1 for styling. We added 0 comment, but I don't think it's necessary to comment such a simple code. So yeah, that would be it for Caesar. And I think we can quickly tackle the next one. So it's substitution. So in substitution, we want to substitute characters instead of just shifting by, for example, 13 positions in the alphabet. We want to actually substitute letters with the letters that were passed as an input to our program. Actually, I think it might be even simpler, because it won't have anything to do with rotation. So we can remove this bit for sure. Okay, so I think we can continue with our problem. So in order to solve it, I think we can copy most of our code. And here we have substitution, which is new problem, but I've already solved it. But don't worry, I'm going to write it with you once again. Okay, so let's use our code from Caesar. Let's modify it a bit. We can call our function substitute, for example. I think it would be a good one. So we need to also adjust the function implementation. Substitute. Okay, so we have substitute here, and our key won't be a int anymore. It would be a string. And we want to check if our key is valid once again, but the criteria would be a bit different. So first of all, we want to check if our string length, if our key length is 26. It's not equal 26, then we want to return false, because that's the behavior that we want. Actually, we have to check more than that, but firstly we want to check length. Then we want to check if it's containing any non-alphabetic character. So if it's not alphanumeric, then we want to return false. And we want to also do a quick check with letter duplication. So I think we would need to have an additional collection, which is the which would be a array of characters. Yeah, so it would be an array of characters. So we have a char with 26 characters, and we want to basically fill in the whole char 26 key chars. Well, actually, we want to use int here without any initialization here. Let's check how we should declare array of ints initialized with 0. Okay. Okay, so I think by default we would get a char. Okay, so maybe int it's better. So it's 26 of them. And we want to check the uniqueness, but in order to do that, you have to firstly assign an index to each letter. So we will do our handy trick with upper A. So we will upper the key at I. I think key at I position, and we want to subtract upper A. This will give a value between 0 and 25, sorry. So that would work. And we want to increase our key unique chars at I position and actually index position by 1. And before doing that, we want to even check if our key unique chars at index is greater than 0. Or if it's equal 0, then we want to increment position. Otherwise, we want to return false, because we will know that it's not unique. And is that it? Is that it? I don't know. Let's check. Yeah, I think so. Okay, so now we have to a bit adjust our substitute function. So if it's an alpha, then we want to convert it okay. So now, in order to get the index, so now we have a different problem. We are not sure if we assign position of here of lowercase version of letter or uppercase version of letter. That's the issue, and we don't know what to do here, because we need to check if this key it's upper or if it's not upper. But maybe instead of checking existence, we could actually assign this key to the proper position. Yeah, I think that would be good. So we are going to get the index like we did here, but instead of checking and instead of incrementing the position at index, I mean, instead of incrementing our counter at index position, we are going to assign our key at I at index position. And because we did that, we could then use it as our key in the substitute here, somewhere there, basically. But let's check one thing about the key. The key itself should be case insensitive. Okay. Okay, I get it. I get it. Okay, let's go back to our problem once again. So they are saying that the key itself should be case insensitive. So whether any character in the key is uppercase or lowercase shouldn't affect the behavior of your program. But I'm not sure if we have any example of lowercase version of key. Not sure.
In some command line argument is necessary, must contain 20.
This video
is not valid. Only contain and provide for J that the key should not contain text. Then you'll need to one of which is an array inside of the key, and you should also check for repeated. Should instead consider other letter, lowercase letters inside of the key.
What does it mean? Yeah, exactly,
however, for example.
Exactly. So now we have an example here.
Well, the key were all lowercase.
Okay, so A, B, C. So the plain text is determining the version of the ciphertext. So if the C would be lowercase, then it should be Z. Okay, so okay. Now I get it. Now I get it. Okay, so our solution might take advantage of that. So at index, actually, we want to do something different, I guess. So at index 0, we want to store the A variant, the upper A variant, for example. So at index I, we want to store key.I and if there is a letter that is the same in the key itself, then we want to quit sooner. Let me think here for a moment. Substitute. Substitute. Okay, so we have substitute here. Okay, so let's start from the beginning. First of all, we want to check alphanumeric, then we want to check uniqueness. So if it's not unique, then we want to assign it at index position. Let's assume that that's the case. And then our upper A would be 0. So let's write it here. So our A would be, so at 0 position, we will know that we have A lowercase or uppercase version of A. I get it. But is that making any sense? We have to upper here, and by doing that we would get an index from the key, so it would return 0 till 25, 0 to 25. So we will know that 0 letter would exist. Basically, I think it doesn't make any difference if we do it like this. So we know that at I position key exists, and that's totally fine. But here, if it's alphanumeric, then we have access to the key at I position. So key at I position would be our substitution. But if we have upper version of our letter at I position, we want to have a upper version of our key at I position. Otherwise, we want to have a lowercase version. And I think that's basically it. Let's check. Let's check here. Let's change directory. Let's go to the substitution and let's make our program. Make a substitution. Substitution. Okay. So we have still a Caesar here, which should be substitute. Substitute. Okay. String int key. It should be string here. Passing arguments to parameter key. Oh, it shouldn't be int anymore. It could be just the key. Okay. Semicolon. Like this. And let's run our program. With example input. Okay, so let's watch the video. Okay, so let's try hello, like in the example. Hello. Nice. It's a bit different, huh? It's a bit different. What went wrong? So H. Yeah, it's not at I position. We need to check this, but it shouldn't be K at I position. It should be K at oh my god. It should be K at I. K at position, which is key position variable, and we can calculate it by checking the key at plain text at I position, making it to upper, and we want to get an index. So now we will have a proper index, and now we can use it as in our array. So now we are referencing key position instead of the I, which should be correct, but let's try it. Hello folder. Okay, so I think it gives us nice feeling of confidence here. So let's use check 50. We are waiting for results. There we go. So as usual, let's use style 50 to correct our code style. Yeah, we have some things to improve on. let's apply those changes. Nothing has changed in terms of the logic, so that's good. Let's run the command again. It looks good. Great. So I think we can submit it finally. Let's submit our version. And let's go to this website. We are waiting on results. And there we go, we have 18 out of 18. So that's the huge success. We added one comment, but this tool didn't catch that, but it doesn't matter at all. So I think that's all for the arrays. We solved all issues together, all problems from the problem set 2. And we will see each other in the next episode when we are going to tackle week 3. And we are going to do some things with sorting algorithms as a start, but that would be explained in the next episode. So stay tuned and thanks for watching. I hope I helped someone with his or her struggles, but anyway, thanks a lot and bye bye.